Now, I want you guys to now try this one next. So again, QA2, we will do analysis. Okay, let me send you QA1, the mark schema. Okay. Now, I'll give you guys a few minutes. I want you guys to do the same thing again. Okay. So I want you guys to again, I want you guys to have a rough idea, right, of predicting of how you want to proceed it. So anytime tomorrow, for some of you that send it, when you ever do quality analysis, do not read the A1 and then start A1. Please don't do that. Must read through the whole thing. Must read through the whole thing, roughly figure out. Okay. I'll give you guys a few minutes with QA2. Okay. Now let's go on to QA2. The idea behind this is that you must be expect the cation anion. Now, why is it? I want to show you this particular question, right? It is because of do you observe one thing? They never put their qualitative analysis notes. all of you observe it, they never write their qualitative analysis notes. Because they never put their qualitative analysis notes. So you look at the mark scheme, right? This is when you see the Fa5, right, for this, right, is sodium hydrogen sulfate and sodium carbonate. Later, the Fa6, right, it is ammonium chloride. Right here, thank God. Because they say both the ions got qualitative analysis. So this one, right, you can refer to behind there. Make sense? But it's only 3 marks. So this one is actually, I personally think it's a very challenging, bit challenging part. This one, is why is it a bit more challenging? Not to say the ions doesn't completely don't have ions inside the qualitative analysis, but they also have some of the ions like sodium and hydrogen sulfate that is not part of the experiment. Now, do you see when you don't see the keyword, both ions are not listed in qualitative analysis, so you have to proceed a little carefully. So I want you guys to take note of this one is actually, I think it's good. 15 marks, right? 12 marks doesn't come from that note. Just on the previous question, at least more than half of it from the notes. But now there's one part, it doesn't come from the notes. So you got to proceed very carefully with it. Okay. Hit gently, hit strongly. Hit gently means the tip, right, of the fire, right, touches the bottom of the test tube, of the boiling tube. You know what is hit strongly or not? Hit strongly, the test tube is right in the middle, about to touch the metal already, That means the fire, right, is reaching to at least 1 cm depth. The fire, right, is reaching 1 cm depth. It's like the fire must be more than the wok like that. The fire must reach at a high level. So you must put your test tube very close to the middle of the fire there. The fire must reach at least half a cm depth or 1 cm depth of the boiling test tube. That's what hit strongly means. Okay. Now, if you want to be sure, right, then you turn from 2 minutes become 3 minutes. So now for this one, right, I will advise you to write anything you can see. So because even if let's just say the solid melts, please write that melts into what type of color liquid. They never put the answer here, right? But no harm in writing even if it melts, right? Because you don't know, sometimes they see award 1 mark for each correct statement. Sometimes it's like award 2 marks, 2 points for 1 mark. So for this one, you just write anything that you can see. Okay. Now, when you heat up something like this, right, most of the time it is decomposition. Decomposition got 2 types. Got 3 types. Can be ammonium. It can be nitrate. And it can be carbonate. This one easiest. This one release NH3 gas. Okay, this one, right, nitrate, right? Nitrate is the easiest to test one. You don't need, be honest, you don't even need to test for the oxygen gas. You can put inside observation gas, realize going splinter. Because you ever hit up nitrate, right, the only thing you are going to form, right, is brown gas. And then this carbonate will give you carbon dioxide. You ask me, right, the problem with this, right, brown gas, right, is you form it after 5 minutes. It's actually take a very long time one. You need to melt, then after it turn black a bit, then later only will form until the brown gas. Cambridge don't quite approve of this because the nitrogen dioxide a bit toxic, so less likely to come out. But I cannot confirm because sometimes I don't know how Cambridge, the way they ask question is. Ammonia, on the other hand, is very straightforward. You will release ammonia gas, you just need to put the damn red litmus paper on the top only. Turn a little bit blue, stop already. Then carbonate is when you heat up the carbon dioxide, give a precipitate lime water. So my honest answer for you, right, is I recommend you test for ammonium first. Why test for ammonium? It is because ammonium putting the damn litmus paper is much easier than testing with the delivery tube first. But if you want to say, so what most of the time will come out which one? Most of the time, actually, carbonate is the favorite of the Cambridge, then followed by ammonium. When it comes to heating it up, this type of thing, carbonate, then followed by ammonium. It's only these possible three answers, because what you have right now is actually a decomposition type of reaction. A decomposition type of reaction. Okay, now here is when it gets a bit weirder. You add water, effervescence form, colorless solution form. So actually you need to test out for the carbon dioxide one. So this one, right, is the observation for this one now will be effervescence form, gas turn lime water cloudy, and then you form colorless solution form. What is happening here? This one is actually, because hydrogen sulfate is a bit acidic. So what happens is that hydrogen sulfate, once dissolved already, right, will react with the carbonate to give you carbon dioxide, H2O, and SO4 2 minus. That's what's going on. The hydrogen sulfate is come from sulfuric acid. Sulfuric acid can donate 2 protons. So here got hydrogen sulfate is part of the, you donate 1 proton, become hydrogen sulfate. So hydrogen sulfate can donate 1 proton, become sulfate. So when you add water, effervescent form, gas turn lime water cloudy color solution form. This one is very hard for you to guess. This one is very hard for you to guess, because can you expect in that one solid mixture got hydrogen sulfate and carbon dioxide or not? But why I'm answering like this is because you're wondering how come add water can form effervescence, right? Because inside there got 1 part solid, 1 part acidic, 1 part carbonate. That's what's happening right here. And therefore, in this one, we add sodium hydroxide, you have no change, because the cation mostly is sodium. If you add sodium hydroxide ammonia, right, and you don't get a precipitate, right, don't panic. First check whether they got say something like it's part of the qualitative analysis notes or not. If they say the cation is part of the qualitative analysis notes, then it's high chance it's ammonia already. Ammonium already. If they never say it's part of qualitative analysis notes, high chance that it must be using an unreactive cation like sodium and potassium. The reason I'm showing all this, although look at mark scheme seems easier a bit, right? But when you are doing this experiment at time, trust me, it will become very confusing one. Yeah. That's why you'll notice at the end they ask what is the anion. They ask what is the anion. Okay, so this one again, add acid, again, effervescence. And this one again will the lime water cloudy. So actually, right, to be honest, right, if let's just say this part here, or you mistook it, you might think it might be ammonium, right? But because this part here, right, you know it reacts with acid, right? What I asked you to read the whole question first, right? When I see this, right, I wouldn't do step 1 first. And then you may say, so how come you want to step 1, but I thought follow A1? I'd rather go this one first. I'd rather do this one first. You know why not? Okay. This one is acid, right? Effervescence form here, right? Gas gives white precipitate with lime water. When it comes to this part here, right, I want you to think about it. Would I have bothered to testing for ammonia? Would I have bothered to testing for nitrate or then not? I'll still already set it up, right, with my delivery tube to the lime water already. Does that make sense? Because here already give me what precipitate lime water. That means I know there's a carbon inside them. Therefore, if I heat it up, I know I'm going to form carbon dioxide gas one. So that's why I ask you guys, whenever you do this type of question, please don't say 3A1, start with 3A1 first, then only figure out from there. Then later, when you come to here, then later you want to backtrack right there. Don't waste too much time on qualitative analysis. At some point, you got to pass up the whole paper one. So what if I reach until the end here? Last 10 minutes, no experiment. Fake the whole result up, please. You guys are getting what I'm trying to say? Fake the whole result up. You must fill in something. You cannot leave it blank. So that's why I say, I rather you guys read the whole paper, right? I rather I will do this part here first, then only I go back into this part. In fact, I'll tell my honest answer to you is that most of the time, right, most of the heating one, right, is testing for your observation skills. I rather leave the heating up part, right, at the not the end, but let's just say, if I were to tackle this whole problem as a whole, I'll tackle B first, then I need to go back to A, because it makes me much easier to tackle with the heating part. Okay, so straight away tell you that there is A2 tells you that there is hydrogen ion, because you from B1, right, you already know there is carbon. Here got carbonate already. So therefore, from A2, right, why add water can work? Because acid is present reacting with the carbonate. Now, last but not least, carry out further tests to identify the Fa5, right? Sorry. Your qualitative analysis, so you realize that you cannot run out is you test out for sulfate sulfide, you test out for the silver halide. So therefore, I'm recommending is don't test out the nitrate and nitrite first. Test out the silver nitrate and test out the sulfate sulfide first. How come? Because it's much easier to test when you just need to take a little bit, add a few drops. Every time you do a heating, right, it will take you about 5 minutes. But taking a little scoop out, taking Fa5 out, just add in the silver nitrate and add in the barium sulfate or barium nitrate, that will take you less than half a minute. Straight away can put in the answer, and then now, if let's say this is sulfate sulfide, right? For sulfate or sulfide, right, I recommend you use potassium permanganate. I recommend you use potassium permanganate to test between sulfate sulfide, because to use acid to test on the barium sulfate versus barium sulfide, right, it's very hard to see whether is it soluble or not. But potassium permanganate, add 1 drop, 2 drops. Is the purple color gone? Purple color gone, decolorize, sulfide. Purple color not gone, sulfate. I recommend you use, that's why they have there, potassium permanganate remains purple, not decolorized. Okay. Then you have the ionic equation, and then you have the anion. Follow me on this so far. This last question not easy to get. This particular paper not easy to get. Brandon, do not put there HSO4 minus. You are not supposed to know that, because it react with the barium chloride, barium nitrate, right? You only will know it's sulfate ion. You will not know it's HSO4 ion. HSO4 ion is the way they prepare inside it. You are not supposed to know it's HSO4 minus. So that's why the answer is SO42 minus. You see right here, SO42 minus. Leah, correct. If KMNO4 turns yellow, right, it's considered decolorized. Okay, Leah, sometimes it turns yellow, right, because inside the mixture, right, there could be an extra star. In fact, if I'm not mistaken, right, the one that is turn yellow, right, high chance is inside there got iodide. KMNO4 reacts with it, iodide becomes iodine, turns yellow. Even if it's turned any other color, it's still considered decolorized.